Hello and welcome again to my channel. In our today's lesson, we are going to look at the signal flow graphs. Then we are saying that the signal flow graphs are alternatives to the block diagrams, and they consist of bridges which represent a control system. That's what we call a flow graph. They are just alternatives for or alternatives to block diagrams. And then we think that they consist of bridges which represent a control system. It is also a graphical representation of the relationship between the variables of a system. That is now a signal flow graph. Just a graphical representation of the relationship between various variables in a system. So of course, when you looked at block diagrams, we had several blocks in that block diagram. But when it comes to signal flow graphs, we're going to have the same parameters, but now we have the change of terms in this case because they are alternatives of the block diagrams. So now instead of having blocks, we'll have another term. Instead of having the summing point, we'll have another term for that. So now I'm going to use this diagram that I've just drawn here to explain the terms that are used in a signal flow graph. And the first term is the first term is a node. So saying that a node is a point representing a variable or a signal. So when it comes to the signal flow graphs, then you are having this term here. So a node is a point that represents a variable or a signal. So of course, this one here will represent a node by having something like a circle or a dot. So that if I come to this block diagram, I'll have this one as my node, I'll have this one as my node, such things. So now instead of having the summing points, we just use the nodes to connect several points or paths. That is the first term. Then our second term is a branch. A branch is a straight or direct line that is joining two nodes. It is represented by an arrow to show direction. So we think that a branch is a straight line that joins two nodes. So now we've known that what is a branch. When I come to this diagram, I find that I have this node here and I have this other node here. So this straight line here joining the two nodes is my branch. And of course, I have to show the direction like that. That's why we are saying that it is represented by an arrow to show the direction. So you have to indicate the direction for a branch. It joins two nodes. Then we have term number 3 is path. A path is a continuous unidirectional succession of branches along which no node is passed more than once. That's what we call a path. And you find that in a signal flow graph, you can have one path, you can have two paths, you can have as many paths as possible. So in our diagram here, I have several paths. I can have this path, which is from x1 to x2, then to x3 as my first path. Then I can still have this path from x2 to x3, then back to x2. So I can still have x2 to x3, then to x2 as my other path. Then when you still look at the diagram, we still have this path from x1 to x2, then to x4. That is from x1 to x2, then to x3. Those are the paths that I'm having in this signal flow graph that I've just drawn here. All the paths are unidirectional. That means it is only the forward direction, but now you should not pass that node more than once. Then we have the next term. The next term is the input node. it is a node with only outgoing branches. Only the term here is what? Outgoing branches. So of course you can see now from my diagram, I have all these all these nodes coming from x1. So x1 has all the branches coming out of it. So this x1 becomes my input node. So x1 is my input node in this case, because you can see that all the arrows are coming out from x1. So that's what we have. Then we have this is x1. Then we have output node. Then we're saying that the output node is a node with only incoming branches. The term here is what? The incoming branches. So you can see from my diagram here, I only have all the branches coming towards x4. You can see this one is coming towards x4. These the others are coming from x1 all through x2 through x3, then coming to x4. So in this case, my x4 is now my output node, because it has only the incoming branches. Then we have the forward path. Then we're saying that the forward path is the path from the input node to the output node. So when I look at my diagram, I have the forward path from x1 to x2, then to x4. When I consider this path, x1, x2, then x4, that is my forward path. Then I still have another path, which is x1 to x2 to x3, then to x4. So I just have here another path is the x1 to x2 to x3 and then to x4. Those are now my forward paths in that diagram. So all the forward paths have input nodes to are paths from the input node to the output node. Let us look at the next term, feedback path or loop. It is a path which originates and terminates to the same node. The path which originates and terminates to the same node. So for instance, we have this the loop here or feedback path that we had from x2 to x3 and then back to x2. That one becomes something like a closed loop or a feedback path that has a forward path and a feedback path. That's what we call the feedback path or the loop. Number 8, we have the gain. We think that a gain is represented by an arrow between two nodes. It is represented by an arrow between 2 points, and in this case, if I have the gain between, I have x2 to x3. It is drawn as from this node to this one. This is my x2, this is my x3. So in between these two nodes, I have a gain, and this gain is what? Is a2. That's what we have. So I can still have from x1, this node here, to x2. I have a gain in between the two nodes, and the gain is what? A1. That's what we call a gain. It is always between two nodes. And then we have to indicate the arrow to show the direction. Then we have the next term is the gain path. It is the product of the branch gains encountered in traversing a path. So when we talk of a gain path, it's just product of the branch gains that we encounter in a specific path. For instance, if I consider this path x1 to x2 to x3, then to x4. Then the gain path will be equals to a1 times a2 times a6. That is now the gain path, the product of all those gains in that given path. That's what we have. Then the next one is loop gain. It is the product of the branch gain over loop. So when you have a given loop in a signal flow graph, then how do you get the loop gain? For instance, we had this kind of a loop here. This was something like a loop. So this loop was x2 to x3, then to x2, was something like a loop. So the loop gain of that loop will be equals to the product of all the gains in that loop, and then the gain is what? Is a2 times a5. That becomes the loop gain of that loop. Then we have number 11, non-touching loops. We have non-touching loops, and then we think that these are loops which do not share a node. These are the loops that do not share any node, and we'll see this one clearly when we'll be looking at examples, how we get non-touching loops, how we get touching loops. So long as those loops do not share any node, then we call them non-touching loops. The next term is dummy node. So we're saying that a dummy node is something that looks like this, something that looks like a loop. But now we think that if I have from x2 to x3, then back to x2, or maybe from x2 to this x3, then of course this x3 will not be a perfect output, because this arrow is coming from the same node, this one is coming toward the same node, so you cannot call it an output node. So we think that x3 is not a perfect node or a sync or output, and therefore there is need to create a dummy node, which is now x3 prime. So in this case, if I have something that looks like this, I have the arrow coming from this x3, and this other arrow coming towards this x3. So of course, I'll not call this one output. I need to create a dummy node, which is now my x3 prime. So I have to show this one by an arrow. So if this is my x3, then here I'll have x3 prime to show now my output. I think those are the terms that we use in signal flow graphs. Thank you so much for watching, and please watch my next video. I'll be explaining how we convert block diagrams to signal flow graphs.